I wanted to go over the chapter 20 quiz. Now, you may not have had this exact quiz in terms of numbers or even subject or topic, but you would have had something extremely similar. I just want to go over the different elements. As I was grading these, I noticed a lot of inconsistencies in students' responses and a lot of responses that were short, that were incomplete, and I'm not sure if it was because you just didn't know what to do or you just didn't want to put the effort into doing it the right way. I just need you to know that if you don't complete it in the way that I'm instructing you, then you are choosing on purpose to lose points every time you do an FRQ like this. And this is essentially the FRQs of pretty much the rest of the year. As we do a phantom or a panic style question, those are the acronyms that I give you to tell you how I'm going to grade your tests, how I'm going to grade your quizzes, at least the FRQ portions of it. I'm going to run through this real quick and just kind of talk about what's absolutely necessary and kind of how we should take these and complete them. Let's talk about P and H to a minute. First of all, P, the phantom, the P in phantom, I don't grade because it's essentially the question they ask you in the scenario. It's not a big deal that you write it down, but it is something that is important that you realize what it is. The question is, they want to know, is there strong evidence that participation, in this case specifically female participation in the Olympic sports? So we're looking to find out, does that happen to increase or not? This particular statement is also where I'm going to find my alternative hypothesis. It's talking about a percentage going up or down. In this case, it's talking about going up. Right? So my null hypothesis is HO colon P equals 0.42 because that's what's saying that in this case, my expectation, my understanding is that 42% of the sports are female, right? Or participation is female. I can't leave off the P. I can't leave off the HO. If you leave off any one of these, this is the bare minimum required for a null and alternative hypothesis. I have to know which one's null, which one's the alternative. You have to use the parameter. If you use P hat here, or if you simply don't put a P or anything, you just put 0.42, I'm marking it wrong. It is a thing that you have to follow. Okay. The alternative we get that we believe the expectation is that we're trying to show something, right? The null is the absence of that thing. In this case, we're going to assume it stays the same. It's the status quo. And so it's 42%. The alternative is that we are trying to show that it has increased, or we're looking to see if it has increased. And that's how you're going to get your null and your alternative hypotheses. Minimum requirements. You can write this out in words, but this is absolutely unnecessary and doesn't get you any extra points. Let's talk about our assumptions and conditions. This is where I see a lot of students really dropping the ball in terms of putting some stuff out there. If you make a list telling me that they're all satisfied, I will treat that as if you didn't even do it at all. Okay, just writing the names down without actually doing any sort of actual verification, especially for 10% and success or failure. If I don't see these numbers and some sort of realistic calculations, then you didn't check them. You are simply assuming it, or you looked at it but didn't verify it. You've got to write it down if I'm going to give you credit for it. Randomness is not always something that's stated in the problem, but in this case, it says right here, a random sample of pre-Olympic exhibitions, right? They took a random sample. They told you that, so I'm simply going to say it's stated in the problem. If they didn't tell you that it's random, then I'll have to say that it may not be random, but it seems representative, or at the very least, we don't have any reason to think this is a biased sample. That's kind of the point of randomness. Independence. I want to make sure that one person participating doesn't affect another person participating, random person, right? So I'm going to write out a little phrase that tells me the reasonable assumption I'm making. Participation is an independent choice. That makes sense. You've got to state it. You can't just say check, right? 10%. 454 is my sample size, okay? That means that I need a population that's at least 4,540 before this is satisfied. The question is have there been 4,540 athletes to participate in the Olympics? And absolutely yes, right? There's been way more than that, right? So this number, 454, is definitely less than 10% of all athletes. Success or failure. I take the null hypothesis value I multiply times my sample size, and I take the 1 minus that value, and I multiply times the sample size as well. I get two numbers. These numbers are not expected to be whole numbers, but I do them, and I tell you how many I expect to have. Both of these values need to be greater than 10. If they are, then it all passes. And at that point, we can move on. The next thing we're going to do is we are going to talk about the mechanics, or really the math, the number part of this operation. Okay, the mechanics. First of all, we're using the one prop z test in the calculator. If you're still using a z-score concept and going to the back of the table and looking that z-score up and finding it that way, you are working 10 times too hard to do this question. It is a calculator-based example. If you don't have a TI-84 and you're working through that, you should have contacted me months ago. I try to make sure that everyone had one of these calculators at the very beginning of school. This is absolutely essential, and you're going to need one of these calculators to be successful. If you do not have one, you need to get in contact with me immediately. We ran through the one prop z test in the calculator. You can find that by going to Stat, going over to the right twice under Tests, and scrolling down to number 5. There it asks me for the null hypothesis. That's 0.42. The x value is 202 people were my number of successes. The n was the sample size, which is 454, and I chose an alternative that says greater than. I calculated that number at the bottom, and I got the results you see on the page. A z-score of 1.076 and a p-value of equal to 0.1409. Always, always, always go to 4 different places. Okay. At this point, this is one of the easiest things of the entire thing to do. The numbers were given to me, and I just worked them out. Right. The next part is to make our conclusion. We're going to be using an alpha level of 0.05 for our conclusion, and this is where I see a lot of mistakes because you're not used to what these things mean. You're seeing it, you're just not quite putting pieces together. A lot of times I'll see people make one judgment and make the exact opposite statement in the following sentence. So let's make sure we pay attention to this piece. Because my p-value is greater than my alpha. In fact, I had some people on this very question tell me that this number was less than this number. You have to look. This is 14%, this is 5%, right? That's clearly larger than this one. Because my p-value is larger than my alpha level, right? I do not have enough evidence. This is a very small p-value, means lots of evidence. That's a little bit counterintuitive. You got to be ready for that. I failed to reject my null. I didn't say I accept anything. I didn't say I accept the alternative. I never accept the null in any way, even if no, ever. Don't ever do that. You either reject or you fail to reject. Those are your two options. Please don't say anything other than those two things. Okay, I failed to reject my null. My p-value is greater than my alpha level. I wrote the alpha level down, so I can simply refer to it here. If I hadn't written this down, because the problem didn't give me one, I have to state it somewhere, either writing it into the paragraph or kind of referring to it at the top. We do not have evidence that the participation rate of the females in the Olympics has increased. We do not have evidence. Anytime you say I failed to reject, your next statement will be we do not have enough evidence. If you reject the null, then I would say I do have evidence. These two things have to coincide. Okay? You can't make one statement and then completely the opposite statement in the next paragraph. I saw that all over the place when I'm grading your quizzes and things like that, especially on this class, on this assignment. All right, the next one. This is, what was it? A one tail, upper tail, lower tail, two tail. What was it? Right? And then explain why we chose that. This is a super easy question. My alternative was that p was greater than 0.42. If I were to draw this this graph and shade it in, really my rejection region would be up here because I said greater than. Anytime it's greater than, you have a upper tail, right? This is the upper side of things. If you said less than, it'd be the lower tail. If you'd said not equal to, then that would have been both sides, right? That would have been two-tailed, right? So here we have an upper tail and it is because we chose an alternative greater than. If I had chosen a different alternative, then I would have chosen a different answer here. The next part is the p-values definition. This is something that you would do well to simply look up in the book if this doesn't make sense. The definition would be something like this. There's a 14% chance to observe 202 out of 454 females participating if the proportion is 42%. Generically, it sounds like this. There is a p-value chance to observe a sample like this one if the null hypothesis is true. That's what you're trying to show. One more time. There is a p-value chance to observe the sample result if the null hypothesis is true. Okay? I kind of put that in context here. If there's a 14% chance, that's my p-value, to observe my sample, 202 out of 454 females participating if the null hypothesis is true, if the proportion really truly is 42%. Okay? And that's the whole thing, right? In this case, you had to kind of run through phantom, and we did that. Then we had to kind of talk about the tails and then writing the definition of the p-value. Make sure that you know those. This is something that's really important. You can't shortcut a lot of this stuff. If you start to shortcut, then you're cutting points off of your total. Keep in mind, right? If you have a question, if you're not sure how to do some of this stuff, we are well beyond phantom right now. That was chapter 20. You should have that down. That is something that is going to get, it isn't going away. This is going to be around for pretty much the duration of the rest of the semester. If you can't get it down, it just means that you're going to have a really hard time in future subjects. So make sure that if this is really confusing to you, that you get in touch with me and we can have a session where we can really nail this down. And this is not complicated. It's just a long process that you need to get exposure to. The more you do it, the better it's going to be. So make an effort and let me know if I can help you.